Okay, with percent of change, you need to have this equation down. So please write percent of change is equal to the amount of change over the original amount. Does anyone have maybe an idea of what we're talking about when I say percent of change? Like, what is that referring to? Yeah, it's kind of a random lesson unless I understand what percent of change is. Yeah?
Amount of change over original amount?
Yes, that's exactly it. So where do you see that? Someone in the other class gave the example, like on Amazon. Do you ever have like a wish? I don't know if you guys have wish lists on Amazon. Or you just look at Amazon, you're trying to find a product. For example, the last thing I looked up for 8th grade was calculators, graphing calculators. All right, how much do they cost? Well, this nice graphing calculator is on a sale. It's 30% price, 30% decrease. What does that mean? It was this amount, but how far did it go down? 30%. So that's a percent of change that goes down, and that's a good one for a consumer. What's another example of a percent of change or change in percent? Any others? Maybe the opposite way? That might not be so nice. Your taxes went from 6% to 7%. And you're like, that's only 1% change, isn't it? But is that big or small? Think about it. Big. That's one of those where people get upset about and start letting people know about that percent of change. So you can go increase in percent or you can decrease your percent. And let's look at both examples. So on page 226, someone read for me that first paragraph that starts sand shack. How about Hudson? Sand shack.
Sand Shack marked up the price of its large iced tea from $1.89 to $2.19. What percent of the increase was this?
Okay, so what happened to that price of that large tea? Did it go up or down? It went up, right? So it was a percent of change that went up. It's an increase. We're trying to find out what percent did it increase. So here, what I want you to write underneath this formula is the basic form we're going to be using in every single problem in this lesson. The percent of change can be written as some number over 100. Some number over 100, and I'm going to put P for percent. Like if you have 20%, 60%, you would put 20 over 100 or 60 over 100. And then on the other side of this proportion, you're going to put the amount of change over the original amount. So I'll put here amount of change and then the original amount. That's abbreviating what we're doing. We're always going to have this little format here. Percent over 100, amount of change over the original amount. Okay, that's what we're doing. All right, so let's see how we do that on this problem. What was the original? $1.89. What did it change to, or what's the new price? $2.19. And we said that went up. So what I need to do is set up a proportion here. And do I have the percent of change? Do I know what percentage it changed? No, that's what I'm trying to figure out. So I don't know, and I'm use a variable x here because that's the number I'm trying to figure out. I don't know what x is, but I know it's going to be over 100. Some number over 100 is going to give me that percent of change. What was the original amount? What was the original amount? It's up there. Yeah, $1.89. But what should go on the top of that second fraction according to your little formula? The amount of change. So how much did it change from $1.89 to $2.19? 30 cents, right? And how would you figure that out? You just do 219 minus 1.89, and you'd get 0.3 or 0.30, right? If you subtracted them. That's the amount of change. Now, how in the world am I going to solve for x in this problem? It's something that should be pretty, like I've been saying it too many times, and I need you to start telling me. Cross multiply. So go ahead and do that. Cross multiply. X times 1.89 is 1.89x. And then what's 100 times 0.3?
30?
Yep, 30, because all you have to do is move the decimal twice. All right. But what do I have to do to find x? Because I still don't have x. I still need that number. I divide both sides by 1.89. So I have a division problem. Which number goes in the box? 30, because it's on the top. It's the top number always goes in the box, and I'm going to go ahead and work that out. So 30 divided by 1.89. That's my division problem. That's the hardest part of these problems, is to divide that out. Okay. Do I divide it just the way it is? No. I got to move the decimal point. 1, 2 times here. 1, 2 times there. And I rewrite it because I get all these little symbols mixed up if I don't. This is my real problem. Now, what the book has you do is round to the nearest tenth of a percent. I'm going to say just round to the nearest whole percent. So the ones place value, which makes it less dividing. So I have a decimal point that now is there. I need to get to this spot right here on my division. All right, does 189 go into 3? No. Does it go into 30? No. Does it go into 300? Yes. How many times? 1 time. So I'm going to put a 1 there, and then go ahead and subtract and borrow if necessary. And then what do? Bring down that 0. Good. Bring that 0 down. Okay. This is where you have to think a little bit. How many times do you think 189 goes into 1,110? What's a guess? Throw it out. 5? Is that it? Is that the guess? Okay. What I do here then is I do 189 times 5, and I see how close I get. So 45, 44, 945. Do you think it goes into it another time? Does it go into another time? Okay, I heard 6, so this is what I'm going to do. I'm going to try that out, because some of you on your own might think, yeah. So 54, 48, 53. All right, I get 1134, so that went too far over. So we're only going to go 5 times. Okay, and that was 945. Go ahead and subtract. And then bring down a 0. And before you do that next division, here's what I'm going to do to help you out a little bit, I hope. All right, are you guys here? 1650? Okay, where did I say I wanted you to round it? To the nearest ones place, okay? Which is right here. But that doesn't mean you just stop right there. You have to look at the next digit over to see, does it make it go up, or does it keep it the same? All right, how do I know if 5 is going to go up or stay the same? If this number is 5 and greater, it's going to go up. If it's 4 below, it's going to stay the same. Do you think 189 goes into 1650 more than 5 times, or more than 4 times? Yeah, so you know what? What's going to happen to that number? It's going to round up to 16. 16. Why is it percent? We're trying to find out the percent change. Was it an increase or a decrease? Remember? Increase. So it was a 16% increase. So that large iced tea, I believe it was, went from 189 to 219, and that's a 16% increase. Okay, that's what you're going to be doing. This division is probably the hardest part. Yes?
Do you round every time?
Yes, you round to the nearest whole number. Yes, for a percent. All right, let's do another problem here. Are all increases or all percents of increase, are all percents of change always going to be an increase? No, sometimes they're a decrease. And that could be good or bad, depending on who you are. The original price of this item was $38. The new price is $24. What am I talking about? Someone read for me on page 226, right underneath where it says to find percent of decrease. The beachwear. Who can read that paragraph, the little paragraph? The beachwear. Henry, thank you.
The beachwear boutique marked down its swimsuits from $38 to $24. What percent of decrease to the nearest 10%?
Okay, and they say to the nearest tenth, I want you to get to the nearest whole. So I'm going to make it a little bit lighter on you with the rounding. So they had it at $38 and then it dropped to $24. That is called a decrease. Okay, good. So how do I work this out? The same way I did the other problem. I'm going to set up a proportion. Do I have the percent decrease? Do I have the percent decrease? What do you guys think? No, that's what I'm trying to find. I don't know what that is. But I know it's something over 100. I know that. What was the original amount? 38 goes where? Top or bottom of the next ratio? Goes on the bottom. The original amount goes on the bottom. And then, what was the amount of change? So how much did this change? What you do is, you take the bigger number, it doesn't matter which one's bigger, and you subtract the smaller number, and you should get 14, right? So the amount of change is 14. Now, what do I want you to do next, everybody? Cross multiply. But what can you do to make your life easier? Yeah, you can reduce a fraction if possible. Do you guys see? Look at this fraction. What goes into both? 2. 2 goes into 14. 7 times 2 goes into 38. 19 times. Okay, so now I can cross multiply. Could you have done it without simplifying? Yes. Do you get the same answer? If you do it right, yes. But the numbers just got a little bit simpler, I hope. All right, so I'm going to cross multiply here. What's x times 19? 19x. What's 100 times 7? 700. How do I solve for x? Divide both sides by 19. Which number goes in the box? 700. It has to be that top number. But what if the top number is smaller than the bottom number? It doesn't matter. It always goes. Top number goes in the box. All right, here's your division problem. Oh no. Go ahead and try that out. How many of you have heard the guess and check method of, dividing? Okay, and a lot of people don't like it because that means sometimes you're guessing a lot and you're not close. I'm going to tell you this right now, guys. As you keep doing this process where you're guessing, estimating, and you're getting close but not exact, you get better at it. It's just you start getting a better number sense. I think of 19 as 20. Isn't it really close to 20? How many times would 20 go into 70? 3 times. So guess how many times 19 goes into 70? 3 times. So here I'm going to put 3. And then 19 times 3 is 57. And it doesn't go into it any more times. Okay? Bring down that 0. I get 130. 19 goes into 130. What? 20 goes into 130 6 times. So 19 goes into 130 6 times, I hope. So I'm going to do 19 times 6. 114. 114. So I bet that right here. Bless you. Remember the decimal points right there? Okay, I'm going to subtract this real quick. Bring down a 0. Where did I want you to round these?
Nearest hole.
Nearest whole right here, or nearest ones place, bless you. So does 19 go into 165 or more times? So what's going to happen to that 36? It's going to become 37. 37% decrease. Yes, you're going to have to tell me if increase or decrease. Bless you. So that's what you're doing. And some of the division problems are harder than others. Yeah, I'll give you that. But you won't be doing many. How many of you are okay with this? Kind of okay? Yeah. I'm going to check to see how okay you are. On page 227, I want you to do number 1 on the try these. 227, number 1 on the try these. You have to give me the percent of change and tell me increase or decrease. On number 1. Try these, number 1. It's a large, really? Okay, how about this? Is it an increase or decrease? Because from the original to the new, you go up, right? Is it a small increase or a large increase? It's a large increase, and your answer should reflect that. If your answer doesn't reflect that, then you should question, wait, I thought it was large. Okay, where do the numbers go? Anyone know where all the numbers go? Great, Hagen, thank you.
We on the first.
Anywhere, either one. Okay, we got our percent, which we don't know.
And then,
How about this? What goes on the bottom?
240.
245. And how about this? Tell me how I get what goes on the top of that second fraction. You take the bigger minus the smaller, always. Whether they're flip-flopped on the original new, doesn't matter. All right, 1470 minus 245. I got 1225. Oh, that's kind of big. Why is that kind of big? Because it was a big increase. So it has to be big. Can you reduce before you multiply? Yes. Do you have to reduce before you multiply? No. I'm going to pretend I forgot how to reduce, and then I'll cross multiply. How many of you did reduce? Okay, if you do reduce correctly, we should get the same answer. All right, so I'm going to do 245 times x, which equals this, if I multiply these two together. Okay. All right. At least I don't have to move a decimal anywhere. Does it go into 1? Does it go into 12? That's kind of fun. Does it go into 122? Nope. Does it go into 1225? Hold on. What's your guess? That's a good guess. So I'm going to do 245 times 5. Whoa, 5 times, exactly. 5% increase.
500.
Oh, don't forget to fill in these extra spots. You should have gone 500% increase. Wait, that's like a lot, isn't it? 500% increase?
Yeah.
Look at the original and look at the new. It went up. You know what 500% increase means? It went up 5 times its amount. So you know what 245 times 5 is? 1,470. So it went up 5 times. 500% increase. How many of you got that? Did anyone get 5% and want to admit it? Did anyone get 5% and does not do, and you don't want to admit it? Okay. That's the first type of problem. If you could do the first type of problem, the second type of problem should not be an issue. Look at this problem here. Did they give you the original? Did they give you the new? What do you think they gave me though? Yeah, this is problem on the try these. This is number 3 on the try these, page 227. They didn't give me the original or new. Guess what they want me to give them though? The original and the new. Man, it's so picky. Okay. All they gave me was a decrease of 9, okay? $9 in this case, right? $9. And they gave me a percent of decrease is what? 20%? Okay. So did the price go up or down? Down. How much did it go down? It says right there, a decrease of 9. Okay, ready? Let's get our proportion out. Do I have the percent?
Yes.
I do this time. I have 20%. Do I have the original amount? No. Do I have the amount of change? Yes. Awesome. What do I do with that to find x? Cross multiply. Before I do that, what can I do? You can simplify a fraction. So 20 over 100, 1/5. Oh, nice. 20 goes into 20 one time. 20 goes into 100 5 times. You didn't have to, but you could. So really, oh, nice. This is 45 equals x. What does 45 represent? Okay, dollars, and that's the original. So the amount, $45 for the original. Oh, but I need to find the new. What in the world? How do you do that?
Subtract 9.
I would subtract 9. Why do you subtract 9? I thought you add 9. Wait. You went down from the original to the new. So you should get 36 bucks. So once you get the original, you got the new because it went down $9. Do you see how it works kind of like the last problem? So it's not really new. They just give you different info. How many of you are comfortable with that? Awesome. Do number. You took it from me. Number 4. Number 4 on the try these. Yes. Mhm. That's the original. Because this number down here is always the original. And subtract 9 to get the new amount. Yes, ma'am. Okay, yeah, I'll put it back. That one? Okay. This one is not an easy one, but if you could do it, you're set on the homework. You should be fine. Oh, yes. Yeah, do you see where I got 45? Okay, and then you see how it was a decrease of $9? So if the original was 45, and a decrease by $9, how would I find the new?
You just subtract.
You would have done 45 minus 9, and that gets me 36, which is that new amount. Sorry. Is this the problem? Uh-oh. All right, this one right here, you're trying to find your original and your new. I don't know. But I do know the percent is 12.5. Or you can either leave it as 12.5 or 12.5. Either one works. I'll go with, I'm going to go with 12.5. And the reason I'm going to do that is because you get a couple of them where you can't turn them into decimals. So what would you do? All right. So 12.5%. And then the amount of increase is 486. And I don't know the original. So I'm going to cross multiply. So I get 12.5x equals 48600. So that's how I got mine. You probably would have had 12.5x equals that. Okay, this is what you do with a mixed number that you can't convert to a decimal easily. Convert this into an improper fraction. So I get 25 over 2. X equals. Okay, how do I solve for this? I can divide both sides by 25 halves, or I can multiply both sides by the reciprocal. So really I'm doing this problem right here, and you can cancel out things, but if you didn't, that's okay. I'm going to pretend we didn't, because that happens. And then I'm going to divide this number by 25. That's going to be my last step. Why do you think I prefer to keep it as a mixed number? And if you didn't, you probably saw why. What did you have to divide if you had a decimal? You divided by 12.5, or you had it divided by 125, right? Is that what you did? Okay. Ooh, okay. Did you guys get the original amount of $3,888? Awesome. Good. That's a hard problem. It's so hard. I forgot to take it off from this lesson. All right. 3, 8, 8, 8. But how do I find the new? Sorry, do I add? I heard add or subtract. Which one is it? Add. Why add? It's an increase. So what did you get? 4,074. Sorry. 7,4. Those are your two answers. If you got this one, you're good. Did anyone do it with the mixed number?
I did, but
It was tough.
I just stopped. I had it, I simplified it, and then I had the times 2, but I didn't.
That would have given you the answer. All right, guys, have a great day.